All right, let's take a look at problem 4.11. So when I come up in the instructions, so we're using this flesh text analysis, and we have some already code created. So we want to look at maybe how that works. You've seen pieces of it, and if you go through the homework, you're going to see additional chunks of this. But essentially what you're doing is you're counting the number of words and you're dividing it by the number of sentences and the number of syllables divided by the number of words. So you're getting a score of how complex are your sentences. Apparently that's going to be my grammar level today. So how complex your sentences are. And so in this case, we've created some code, and poor Jack has made a pretty decent program. So even though it says Jack, apparently his authors can't, well, whatever. But so we open up a file name, and we get a file, and in this case, that file has your text document in it. So nothing unusual. We open, and here we put in the file name. We're read only. And then we actually take that entire file, read it into one variable. So it's now all stored, however big that file is, inside a text. Well, we need a way to count then those sentences. And so there actually is this dot notation. The count is actually pretty handy because we can actually get a count of specific items. We know that all sentences typically end with a punctuation. I've seen some student examples that have no punctuation, but we won't count those. So we know that we end with a period, a question mark, maybe we have a semicolon in there, a colon. So we can do this so that we can add in all those items based on how many sentences we're going to have. So if we look at these different items, we're using the text.count, and that passes in to this value of sentences. So we know how many sentences we have. We can use the length and the split to calculate the number of words. Perfect. So we have some data then about this. So now we need to figure out the number of syllables, and this is where it gets a little tougher. Unfortunately, Python doesn't have a magic way to do your syllaba or syllables in every sentence. But because Python makes life a little easier for us, we know that we have some pretty easy or easier ways to do that. So let's take a look what we have here. We're going to count the syllables. So syllables we already set to 0. So we know that we don't have any extraneous values going on. Sentences are 0. This is really kind of a constant for us, although Python doesn't have a technical constant. And we just did that as a string. So A-E-I-O-U, A-E-I-O-U. And the reason we had to do those lowercase and capital is the computer sees those as two different things. And if we think all the way back to when we looked at ASCII, they've actually got different values for them in ASCII. So here we search then. So for this loop, for word in text.split, in other words, every word in here, it's going to go from one word to another until it gets all the way through that text.split that we used earlier. Great. So for vowel in vowel, so we created a new variable called vowel, and so it's going to step its way through this particular structure here. And syllables then, every time it counts one of those inside of a word, a vowel, it's going to call that another syllable. So if I had, and maybe a text document would make some sense. So wherever I put it, hello. There we go. Machine's being a little slow here. So if I have a word, so each syllable we're counting by the fact that it catches a vowel in there. All right. Problem is, what happens when we have a term like balloon? even if I can't spell balloon. So now we have two syllables side by side, and so this program has a little bit of an issue with that. So it counts a syllable. So for balloon, instead of being two syllables like we know it should be, it counts 3 because it has that second O, and it's going to count every time we have a vowel in our sentence. All right. So what this does is scroll through those vowels here. So this is going to make a loop for every one of those and count those up if that value is here. So when this is the value of A, it's only going to count that if A shows up in that sentence or in that sentence or word. And then we have some others. So we know that things that are silent on the end, like ES, ED, E, and there may be some other exceptions. Here we take one back away from it. So we check through our word. And then we also know that some words, for example, that end in LE, it adds one, and this particular thing won't work. So it seems to work fairly well, except for when we have, let's see if I can get it to open the right file name. Oh, I have to put it in, and I didn't do that. Okay. So what can we do to change this just a little bit to make life better for us? Well, I have some suggestions and some thoughts. So the problem is when we come into this, it's going to automatically count each vowel. What if we came up with some way to also look for the fact, are they double vowels? So I might come in with, we need a new kind of a placeholder here so that we can see if it is a multisyllable or single syllable. So when we have those duplicates. So we need to think about what we're looking for. And what we're looking for is, do I have a vowel followed by another vowel? So there are a lot of different ways we could do that. We know that positioning, we could look one space ahead and see, because the most problematic ones are duplicate. So we could see if there are two characters that are the same. And so words like balloon, we could obviously see, and then we could just take one back out. But I think there might be some other ways to do it, because we might run into some that seem weird and don't have duplicate vowels. So let's look at this idea. So we're going to modify some of our code here a little bit. So we know that the word up here, I guess you can't see me pointing. Each time we grab that word, that's a new word as we're working through our program. So what if we did something like, let's just look at each character, and we'll just call it that. I don't think we'd used that before. In Word. So now we're starting to pull through Word, and we may need to come up here because we do this each time. We may need something to trigger this off. So what could we call that? Let's call it vowel existing. And I'm going to go ahead and just set this to, we're going to use those Boolean terms. We could just set it equal to 0. It makes no difference. But as it comes down here, this vowel existing is always going to be set to false. So when we start into this, it's already setting in as false. And actually, hang on. Let me copy that, remove it. I actually need this above that for loop. Sometimes I can't talk and type at the same time. All right, so for character in Word, we can use our if-then statements. So we can make a decision. So if, and we know up here we've already set that to false. So I'm going to actually do a double negative. So if that isn't false in a negative sense, so not vowel existing. Now, I don't need to do this for everything. So if I've already said it's false, but what I do need to do with it is if it is in those vowel lists. So if not vowel existing, holy cow, and the character exists in vowels, so we need to come in one more, and I know, let me move this over, make it a little easier to see. Let me move that over, move this over. Try to give us some more space here so it'll look a little more structured. So if we don't already have it tagged and that character is in vowels, then we need to make some decisions based on it. So the first decision I'm going to have then is I'm going to add one to syllables. Equals syllables plus 1. Yes, I could have used the plus equals. I just like writing it out that way. It's weird. The other thing I'm going to do then is I'm going to then flip vowel existing. So it was false. Now I'm going to assign it the value of true. So false or true, zeros or ones, kind of works the same way. Well, otherwise, if that doesn't show up in vowels, so if it doesn't show up in vowels, I'm just going to flip through here and it's not a character I need to worry about then. So I could use a not character in vowels. So in other words, this says that it is a character in vowels. This says it's not a character in vowels. But I'm also looking at what this flag is here. In this case, I don't need to. I just need to say, hey, it's not in my list of vowels. And in this case, I'm just going to make sure that that vowel existing is equal to false. So I've done something a little different here. I need to keep so what I did was I changed that piece that said this is how we're going to add those up. So now it only adds up if it's not a duplicate or there's not a second vowel in there. So I don't have that file in there, so I need to take that and put it in there. But this should then give us that idea. So we're only checking each time so we get the same value So we're adding to syllables, but only if it's a single vowel. All right, take a look at that, practice it, try it. You'll need to make sure you have that file in there. Sometimes I will go to grab the files and I will put them all into my own folder, and I will just do it in idle. And honestly, that's what I did here, because I find it easier to use idle. So there we go. Copy. I like the idea of idle. I think it just works a little easier. I just copied that whole thing. Certainly I would change that. But what we're looking at is we've just modified. We've taken an existing program and had a little bit of a logical flaw, and so we're hopefully correcting it. So that's one method. Is that the only way? No, clearly not. There are lots and lots and lots of ways to do this particular issue. One thing I did discover from several students is that you can't directly email .py files. So if you want to send a file to me to look at for some reason, change the extension to .txt, and I think that will slip through our email spam filter. All right. Thank you very much.